Hello, my name is Silmith, and today we're going to be doing a really simple tutorial on how to make a set of blinking lights using a AVR microcontroller. I've opened up Atmega Studio 7, which is where we're going to do all of our editing. It's a little bit wonky right now in the UI, I'm not sure why, but we'll bear with it. The device we'll be using is a Arduino Mega 2560, which uses an Atmega 2560 as the core chip. And our objective for this is to have 4 LEDs that will blink on and off again with a controlled by a timer. And we'll have 4 input buttons, which are going to control whether a light is going to be on or off while it's blinking. I've got a bit of a skeleton code here with most of the things that we need. It's got to have a debouncer here to make sure that the buttons are operating correctly. And we've got the timer and some of the things that we're going to need included. I/O, delay, standard library, interrupts, and the SFR defs, which is going to be used for the bit is clear in the debouncer. So let's go ahead and get started. So the first thing that's going to need to be done is we need to set up our ports for input and output. And we'll do that right off the bat in the main function. And we're going to have the outputs in port A. So we'll get that set up. Get them turned off to begin with. And then we want to set up port B for inputs. We're only using the lower nibbles on both of them. There we go. And now we need to set up our timer. We're using timer 1, it's a 16-bit timer. Get it turned on. Set the timer count to 0. Start off with, and then we'll set it to a 256 prescaler, so you get 1 tick every 16 microseconds, and you get 1 blink about once every second. Oh. B, not V. And then finally we'll set the interrupts. Alright. So now we need to set it up so that it's going to blink on and off. And we'll set that in the timer. The first thing we need to do is set up a global variable. It has to be volatile because it can change whenever. And it's an 8-bit integer, so it's just going to be on or off, so 1 or 0. And then we'll come in here into the timer and say every time the timer overflows, become the opposite of what it's supposed to be. Another thing we want to do is prevent slamming the output every single cycle through, which is going to happen a lot. So we're going to set another volatile variable called changed. And we'll put that in here as well. And so what it's going to do is, when we're doing our main cycle here, which we're going to set up now, we're only going to actually write to the registers every time there is a the variable changed is 1, and then as soon as we write to the register, we'll turn changed off, and that way we're not hitting it several thousand times per second. And before we go in there, we need to set up the variables we're going to use. Going to need an index variable. Going to have whether the lights are active or not, and we'll set it up so that when we turn it on, we'll know that it's working correctly if we get this particular pattern. This is going to be for the buttons, whether they've been pressed or not. Oops. We want them to start off not pressed. And we're going to set up an old pressed variable. And we'll use that a little bit later on. So the first thing we need to do is set up the lights themselves. And so we're going to say if changed. So this section is only going to actually activate if the changed variable is active. And the first thing we want to do inside of it is turn changed off. Then we want to see if it's blinking or not. If blink is turned on, then we actually want to turn our lights on. If it's turned off, then we don't. So we'll set that up first because that's nice and easy. So if we want everything off, we're just going to say port A equals 0x00, turn everything off. However, if it is blinking, then we need to activate the, well, currently active lights. So we're going to do a quick for loop. Just over 4 numbers. And we are going to say if the current number is active, then port A is going to get, oop, not that, is going to get a high bit on the on the current index. And the way this works, if you turn it off, it won't turn off until the next time it comes around, since you're OR equaling it, which is fine for the purposes of this tutorial. And so that is simply the light control. So now we need to add some button functions or functionality in here. And we want to do this every time we go through a cycle. So we're going to say Same thing, just go over the 4 buttons. And we're going to set old pressed current index to the new one, or to the current pressed. And we'll set the current pressed to the debounced one. Now, the debouncer basically makes it so that when you push the button, it doesn't actually register until you have a clean contact. It waits several cycles to make sure that, yes, it really actually is pressed. And the other handy thing that you get out of it is once you press it, you can hold it down as long as you like. It's only going to register as a single press. Then as soon as you let up, it says, oh hey, it's gone back down to 0. We'll call it good. So we get this new pressed here, and now we're going to go right to the meat of it. Let's say if pressed is a 1 and old pressed is a 0, then obviously you have pressed it in the past, but it was clear before. This way, the next time you cycle through, it's going to look and say, well, it was pressed and it's currently pressed, so we don't need to do anything with it. We're going to come in here and say, well, it was pressed, so active eye is going to swap whatever it was, become not active eye, and if nothing had changed, then set it to 1. This way you're not going to accidentally overwrite changed, so that's why you check. But if any one of them is pressed, then it's going to go ahead and go through. And that is pretty much it. And we're going to go ahead and have a quick demonstration of that over in the corner here, just to show that it works. So we'll build it real quick, make sure the solution's nice and clean. And go ahead and plug it in. Send it over. Something seems to be wrong. Well, this is the fun of debugging. Let's see. Well, I'll take it back to where I have it in my notes over here. And try that again. There it goes. Well, it doesn't particularly seem to like this, the old pressed setup. So it might not even be necessary. I'll just completely take that out of there. I've used that successfully in other programs, but it doesn't look like you really need it. So we'll go ahead and let's clean this up, make it a little bit better. And do a clean solution real quick. And there we go. Okay, cool. So like I say, I'll have the demonstration over here on this side. It's actually probably running right now. But thank you for watching this demonstration on how to make a blinking light with a AVR Atmega 2560.